Vertisols are really a common soil in a lot of parts of the world. I've read about them, but we don't see them very often in British Columbia. It's a fairly uncommon type of soil. And so do you want to give us a little bit of background on why we have one in this location?
Yes, these vertisolic soils were just entered into the Canadian classification system in 1998. And in the manual it says they're sporadic in southeastern BC. And we have found one here, and I found a few others in the local area. What we have here is a glaciated landscape. If you look over to the south here, we have a drumlinized till plain. The glaciers went over the ground and just smoothed out these bullet-shaped ridges. Up here we have a basaltic mountainside, and then we have some alluvial fans coming down from that. And in this area here we had a lake bed. So what happened as the ice was melting is the clays that were derived from these basalts were washed down and filled in this lake. Mm-hmm. And it's in this lake where these clays, these special shrink swell Smectite clays, developed and gathered, and it's in these particular clays that the vertisolic soils develop.
I'm kind of interested in where this vertisol here lies in the landscape, and it's also kind of interesting there's a fence down here around it. Why is that, Ken?
Well, the vertisols, in fact, we may actually be standing on them here because we're beginning to see the surface cracks develop. It's been very wet over the last few weeks, so the cracks aren't really prevalent, but I think we're in the transition here between the grassland and the true vertisol over here. The fence was put up a couple of years ago for a few reasons. One, people were driving their four-wheel drive trucks through these and just destroying the environment. And the other thing is, I think you see in the background, there's some cattle which also were trampling that area. The faculty at Thompson Rivers University, the wildlife faculty member, Carl Larson, thinks that these soils may be habitat for an endangered toad species called spadefoot toads. And some of our students have been actually working on those. Mm-hmm. So BC Parks has fenced that area off to preserve it from cattle damage, off-road vehicle damage, and to actually see if there actually are toads in there.
Okay, well, why don't we head down there and have a closer look then?
All right.
Okay. Can't really notice on this landscape there's lots of undulating topography here. What's causing that?
Art, this is a feature, one of the surface features of vertisols is called Gilgai Topography, and it's rise and swells. The clays, when they shrink and swell, they move up and down, and it produces these little micro ridges and micro swales. Mm-hmm. Within these soils. So this is one of the features you look for when you're looking for vertisolic soils, is this undulating topography. When in the wet season, when these soils are saturated, the swales will have standing water in them quite often in the vertisols around the world. We don't really see that here, but we don't really get enough rain here. So that's one of the surface features, is this undulating topography. Art, the second surface feature that we see in the vertisols are these cracks that develop as the soil dries out. When the soil dries, these clays shrink. The water within the clay plates moves out and the soil begins to crack and open up. The drier the soil, the larger the cracks, the deeper the cracks will go. At this point in time, it's been fairly wet here. These cracks are just beginning to form on the surface, but given a few weeks of hot, sunny weather, they will go down to quite some depth, probably 20, 30 centimeters. There's another feature that you'll see in these soils is when you dig a soil pit through these mounds and depressions, the soil moves and creates these features called Slickensides. And when we look at the profile, if you dig it broad enough, the features you'll see are these bowls that develop through the depressions. So the depressions are down a bit, and the Slickensides, these sliding features, move out towards the sides. So in a profile, if you dig it wide enough, you'll see this bowl kind of feature in the depressions.
This vertisol seems to be a real mixture of colors and surface features. Could you explain why that is?
Well, Art, it's all in the nature of these particular clays that have these shrinking swell properties. One of the environmental criteria required for vertisols is that you have to have a wet season and a dry season. and we're just starting in the dry season here now. As the soils dry out, they begin to crack, and you can see it opening up here. It goes down, comes across in here, and it starts to pinch out about here. When it gets drier, it'll actually probably go down a little bit farther. As the crack opens at the surface, material falls into the crack, drops to the bottom. When it rains, water then comes into the crack, and the clays begin to absorb the water and begin to swell. And the crack begins to pinch off at the bottom. And the clays then move outward from the base of the crack, and you get this mixing of the material that's fallen into the crack, begins to then move back up in the profile. So we can see some soil mixing here. Come down here, we have some soil mixing there. You can see the different color, some mixing in here, and your matrix or your main color is the brown around it. And if you look at the PEDs that are sitting next to you there, in this example here, you can see a nice crack coming down there into here, and then we've got a mixture of two distinct colors, even some calcium carbonate being mixed in there. So that's what happens, and that's why these clays or these particular vertisols seem as a real mismatch.
Could you tell us a bit about the horizons that you see in a vertisol?
Well, in this particular one, we have 4 horizons. The surface horizon is what we call the AH, little h for humus, and it's not very deep. It only goes down a few centimeters. And it's, in this case, quite dark, organic matter incorporated from the grasses and the decaying of grass roots. And that one is, when it's dry, is this really granular, fine granular structured material here, and it is also mixed slightly with some other colored materials as well. So this soil mixing in this vertisolic soil also occurs on the A horizon. Underneath that, where the cracks begin to develop, there's a crack going down here, you can see the cracks occurring all through here, we have what we call the BV. The letter V stands for vertic. So our BV horizon comes down approximately to about here. And if I was to look at the color changes, I could probably draw a line somewhere up across the profile, somewhere like this. So that's my BV. And here's an example of a BV horizon. And this example here shows the darker clays. And then if we turn it over, we can see the lighter clay that's been mixed in with the darker material. The colors can be highly variable. This is light gray versus dark gray, and in the profile we've seen some other colors as well. It's the color change, these 2 and 3 different colors that you see in this horizon that make it the BV. Art will look now at the soil structure. The PEDs are quite angular in shape, so we would call this structure angular blocky. So there's angular edges to the faces that we're seeing in here. Sometimes you could call it subangular blocky, where they're a bit more rounded. Now, what happens as you go down in depth, there's pressure from the weight of the soil on the surface, and there's swelling of the clays from the bottom. And when these two forces meet, there's pressure there, and it causes the clays to slide against one another. And that produces the smooth, use this one here, these smooth surfaces called Slickensides. So this is one clay mass moving against another. So these Slickensides occur in a horizon called the BSS, SS for the term Slickensides. And you get these very, very smooth surfaces, and when you find them in the profile, they'll be quite shiny and very, very smooth. This one is dried out, so you can see that the vertic cracks are beginning to develop on the surface of these Slickensides, and that'll lead to some structure development later on. With our Slickensides, we get another structure which is unique to vertisols, and it's called a wedge shape. So there's a Slickenside surface, and we can see cracks beginning to develop in the surface here. And those cracks will extend down and produce this wedge shape PED here. So let's look at another example that's been taken out of that. If you look at this, you can see there's a distinct wedge shape pattern developed here. These wedge shaped PEDs usually develop at the base of a slickenside surface. So there'll be a slickenside surface, and as it cracks, these wedge polygons develop downwards. So this is a unique structure for the vertisolic soils. Once you get to the sea horizon, you will not see this particular structure. Now, the sea horizon is usually fairly easy to see because there's a color change, and also the material is quite massive. It doesn't have the structures that we saw up in here, these wedge-shaped beds in the angular blocky. So this was found in the sea horizon, the CSS horizon. The other thing about slickensides is that they sometimes may appear to intersect. They don't actually intersect, but here's a slickenside surface here where one mass is moved this way, and there's another slickenside surface over here. And that's the only example where I've found them that are nearly intersecting.
So you've been showing us some really interesting structural features of this soil. Obviously, it's a very dynamic soil, and that is likely derived from its texture. Could you now talk to us a little bit about how a soil scientist determines soil texture in the field?
Sure. These soils, by the way, have 60% clay or more in them. And there are a couple of ways of doing soil texture. One is to take the soil sample and make what's called a ribbon out of it. This is a piece of soil or a small ped that I've taken out of the sea horizon, and I'm going to just mix it all up. If this was dry, I'd have to wet it and make what's called a ribbon out of it. And if you push it up like this, if there was a lot of sand in this soil, there is no way that that would hold together. You would try this process and the sand would just drop off the end of the finger. There is no way you could make a ribbon of that length. So when you have a lot of clay in the soil, the clay holds itself together, sticks together, and is quite plastic, which means we can deform it.
And even silt wouldn't stick together, wouldn't hang together either. So
based on the length of the ribbon determines what the soil texture is. So you just have a chart that you would compare your length with.
And it would have to be fairly moist when you're doing that.
Yeah, you need to have it moist. This is moist. If I tried to do this with the piece of this, which doesn't want to break off, I would have to take a sample of the dry clay. I'd have to moisten it, and I've actually tried to do the soil texture in this high clay content soil by moistening this. It's impossible to get this saturated to actually do this particular test. There is so much clay in it. So there's the ribbon. The other way you can do soil texture is to make what's called a wire. In this case, and this is the way I prefer, you actually roll it out between the palm of your hands, and you see how long you can make this thing before it breaks off. And you measure the length of this to determine the amount of clay content. You just compare that length with the values in a table.
So a large part of the Vertisol story has to do with physical properties, structure and texture and so on, but we should talk a little bit about the chemistry of these soils and how that might influence plant growth.
Well, first of all, the soils, the clays require high base status, so there's lots of calcium and magnesium in the soil. And the calcium and magnesium is inherent in the basaltic bedrock that was weathered to produce this. With the addition of organic matter on the soil surface from vegetation, that organic matter will lower the pH of the soil, which will actually reduce the verdict qualities. And that usually occurs in the little depressions that we have already seen. In this particular soil, we're going to take some hydrochloric acid, 10%, and see what happens as we drop it on the surface of the soil. There's no fizzing in the AH horizon. A little tiny bit of fizz in the BV, which tells me there's calcium carbonate present in the soil there. If we come down to the BSS, there's quite a bit more fizzing. And then if we take a little piece out of the bottom here from the C, and we drop some acid on that, it fizzes considerably. So there's a lot of calcium carbonate in this soil, which is good for plant growth. And I have a ped over here to my right, where you can actually see the calcium carbonate has actually been concentrated by the verdict processes that have been taking place in the soil. So you can see it fizzes quite readily. The vertisolic soils worldwide have been used for agriculture. They are fairly fertile. The problem with them is how to cultivate them when you have this wet, dry season. If you try and cultivate them when they're soaking wet, then your plow is going to get stuck. And most of the countries that have these soils, the people don't have mechanized equipment. If it gets too dry, you can't plow it as well, because you've seen that some of these pieces of soil, when they dry out, get very, very hard. In British Columbia here, these sites appear to be covered with grasses or meadow-like vegetation and have been particularly grazed by cattle. These are not farmed that I know of. We only have a few sites that we've identified at this time. So cattle grazing is the main land use, I guess you would say, that occur on these particular soils.
What are the determinants of the soil biological processes in this soil?
Well, first of all, the clay is important, and then the carbon is the most important biological component. The carbon is derived from the plant roots and the decomposition of plants. Carbon falls down through the cracks and gets incorporated in the soil further down, and it gets bonded with the clays and becomes quite stable. These soils do have what we call a high cation exchange capacity, which means they can hang on to the base cations, calcium, magnesium, etc. This is more from the clay content than the organic content in the soil. Probably biological bacterial activity going on in the soil and taking place. We have grasses and grass-like plants growing on these soils. Their rooting depth is variable, very fine roots for the most part. Some of them go down quite deep and others do not. So it's very hard to say exactly what's happening, and you can't really put any specific definitions or limits on what's going on in here because of the dynamic nature of this particular soil.